Who here likes dogs? I do. I see by a show of hands, everybody likes dogs. So I'm going to go to a website called what-dog.net. And on this website here, it's a public site you can go to if you want to. It shows pictures of dogs, and it will tell you what breed of dog each one of these is. So for example, this one right here is use this photo button, and it is a Scottish Terrier. That is correct, it is. Let's see, that one, I don't know what that is. That's a Papillon. Here's an easy one that everyone gets. Dalmatian, yeah. Just so it's not cheating, I can grab a picture from my own hard drive or search the web and find one that way. I can go up here and type in like Lassie, who was a dog from my childhood, and I'll go out to Bing search and find pictures of Lassie. I'll take that one, use that photo, and it's a collie. Lassie was a collie, that's true. It's pretty good, actually. This thing probably knew more about dog breeds than most of our audience, I bet. How many of you knew what that Papillon dog was? Let's try another site here. This is similar. This is called how-old.net. And this one also looks at pictures. In this case, it looks at pictures of people. And in those pictures, it'll find the faces, and it'll tell you how old each person in that picture is. So I'll do this one right here. And those people look about 31 years old. That sounds reasonable. Let's grab this one right here. There's 3 people there, including a little baby, 2-year-old baby. That makes sense. Here's one where she's not even looking at the camera. Still got her age. Looks pretty reasonable. And again, you can search online for other ones, or you can use your own photo here. I actually have a folder on my hard drive of pictures of me, like you do. And there's a picture of me. It's a little bit depressing how accurate this thing can be. Really, I'm going to get rid of that, you naughty person there. What's going on here for these 2 sites, howold.net, whatdog.net, is it is using machine learning to analyze lots and lots of pictures of dogs, of people, of all sorts of things, actually. And that machine learning has already been done for you. Machine learning is a hot topic right now. If you're doing machine learning, actively doing machine learning now, I encourage you to look at Microsoft Azure, which has some nice tools to make machine learning easier. But machine learning ultimately is hard. It's a hard problem to solve. It's a little bit better because now we have access to lots and lots of compute power in the cloud, and we have lots of tools like ML Studio that will help you. But ultimately, it requires a lot of data, a lot of compute power, and a lot of time to do machine learning. And most of us have none of those things. But Microsoft does. And as I said, I work for Microsoft. And Microsoft has a platform called Microsoft Azure. Azure is Microsoft's cloud computing platform. It consists of dozens of data centers all around the world. Each data center consists of thousands of computers. They're football-sized buildings with racks and racks of servers in them. And you can use that compute power to run your processes. Instead of buying lots of compute power, lots of computers, you can just say, well, I'm going to rent them for a little while, run my machine learning process. And that's what Microsoft has done with image processing. The idea behind machine learning is that it'll do predictive analysis. It'll say, here's a bunch of data. Here's some information about the data. For example, this field is, it can be one of these values, or a range of numbers in this range, or it can be a binary, true, false, or 1, 2. And you give it some information. You say, how do you want to group the data? And it'll come up with predictive analysis to say, if I give similar data that the system has not seen before, it'll come up with an algorithm to say how these properties of the data are related to these properties of data.
Hey, David.
In this case, yeah.
Let me interrupt here. Right now, I'm still seeing just the YouTube video. Is there supposed to be something else up?
Nope. I'm just talking.
Okay, good. Okay, thanks.
Throw it back to here. So in this case, the machine learning that's been done is looking at pictures, lots and lots of pictures, and looking at the properties of those pictures, and then figuring out, based on just the arrangements and colors and intensity of pixels, what breed of dog it is, Where are the faces located? What is how old are those faces? What does a 55-year-old man look like? What does a 2-year-old baby look like? Analyze the wrinkles around the eyes and the wrinkles around the mouth and the shape of the head and so on. Or in the case of breeds of dog, the length of the hair and the shape of the nose and the shape of the ears. All that takes a lot of machine learning, a lot of punching through data. That's already been done for you. And once it was done, what Microsoft did is they exposed that algorithm as a simple web service, actually as a set of web services. And collectively, those web services are known as cognitive services, Microsoft Cognitive Services. And you can use those. They're available to you, and they're free. So they're free, not unlimited free, but free for thousands of calls per month. And I do this presentation quite a bit, and I've never come close to running out of these thousands of calls per month. So what you can do is if you go to Microsoft.com/cognitive, we'll get you there. It actually redirects to Microsoft.com/something/cognitive services, but that gets you there. And then here you can sign up for it. You'll need a Microsoft account, like an Outlook.com account, and then you can call these web services. And I'll show you an example one right here. This is the image analysis service, facial recognition service, and you can see it's already called this first one here. There's a picture of 1, 2, 3, 4 faces it detected. Apparently this blurry lady in the background, it wasn't able to detect her, but it detected these 4 faces, and it returned some JSON. And JSON is just a standard way of exchanging data over the internet. It consists of curly brackets and semicolons and colons. It's nice and lightweight, so it works really well across the internet. And it's hierarchical, so you can exchange some relatively complex data. In this case, it's returning an array. The square bracket means an array, and an array of face objects, and for each face, it's returning a rectangle, and a rectangle has a top, left, width, height, and you can see that they've written some JavaScript then to actually draw the rectangle around this. And then also the scores. This is actually the emotion API that's being called here. So the scores in this case are anger, contempt, disgust, fear, happiness. There are 8 possible emotions, and for each emotion, it's returning a number between 0 and 1. And the closer to 1, that number is, the more likely we're seeing that particular emotion displayed. So in this case, you can see everybody here looks pretty darn happy. And so for the first face, we see that person is 99.9% happy. And if we scroll down the second face, it looks like happiness is 95% happy. So maybe that's this guy, right? It might be this guy whose mouth is maybe obscured a little bit by his beard. This person is 99% happy. These people are unambiguously happy. You can see scores for anger are 10 to the -6th, contempt 10 to the -8th. They're all really, really low values for every other emotion. It does it for all the 4 faces that it found. And I could grab another one. Let's see. Here's one with a different emotion on it. There are 2 faces, and face 1 says it looks like the highest number is surprise, 99% surprise. This one was 72% surprise. Looks like 18.8% neutral. So you see there's more than one possibility here. It gives a score, a relative score about how confident it is that it's experiencing that particular emotion. And this is just one service is available. If I go to, if I scroll down a bit, these are the categories of services. Now they're broadly grouped by vision, speech, language, knowledge, and search. And there are some labs here that you can work through, but those are the broad categories. We're going to focus today mostly on the vision stuff. I've got a little bit on speech and a little bit on language that I'll show you. Most of the stuff I'll show today is on vision. But if you want to drill down into the emotion API we were just showing, or this computer vision API, let me drill down into that one. And right here, you can see an example of what's the information that's returned by the computer vision API. The computer vision API actually has several different methods you can call. So this one is just information about a picture. You can see things like a description. It includes some tags. There's actually two sets of tags here. The description is a man swimming in a pool of water. And actually, if I look at it, that's a pretty accurate description. It even gives you a confidence level. 89% sure that it is in fact a man swimming in a pool of water. There's some more tags down here, each of which has its own confidence level. Water, swimming, sport, pool, they're all pretty good, and you can see the confidence levels pretty high for each of them. All sorts of information about this image, like the type of image it is, the size, is it clip art, is it a line drawing? It is not. Is it black and white? No. Is it adult content? Is it racy content? It actually gives a score between 0 and 1, and the closer to 1, the more likely it is to be adult or racy content. I think the difference between this is that racy score means that it's showing some skin. I think that's really, this fellow's got his shirt off, and so he's got an 18% racy score, much higher than the adult score. Adult score would really be inappropriate material, like pornography would be, have a very high adult score. And this would be really useful if you had, let's say you had a website and you're allowing your users to upload images and then showing those images to the public or to your audience. That's a high risk thing, right? And the way that people get around that is that if they allow users to upload images, they'll probably have a human being look at those images and approve them, make sure that they are appropriate for whatever audience we're showing this to before they publish them online. That's a very high cost, very time consuming operation. And why not call this service and say, let's get a score. You can see it's a score 0.07 for this particular one. If the score is, let's say, below 0.4, it's probably okay. We'll just publish that. If it's above 0.9, just throw it away, kill it with fire. It's dirty pictures. We don't even look at it. And then maybe in between there, that you'd have somebody look at them and decide whether they're appropriate, or whatever rules you want to. But the point is, you can automate, or at least semi-automate, some of this process to vet these images. What else do we have here? Here's faces. This is probably what was being called in the how old website. In the back end, it's probably calling this web service because it returns, you'll notice, a face with a rectangle, and you see they've drawn some JavaScript around that, and then also the age and the gender. And the JavaScript also, they wrote, has a tooltip that says gender male, age 36. And some information about the color as well, things like that. So you could categorize images if you wanted to. And let me grab a couple of them here. There's some you can return landmarks in here. If I scroll back up, I'll see this is a black and white photo of a city, 95% sure that's true. Down here, I wanted to look at, of course, these are not at all racy or adult images. This one right here is interesting. And the reason this one is interesting, this is a line drawing, where one of the categories is line drawings. So that'll be true. It's actually a line drawing of a lion drawing. And there he is. The reason I thought it was interesting is because it gets it wrong. You'll notice that the description is a drawing of a face. Totally wrong here. However, it knew it was not, it wasn't really confident. I gave it a confidence level of only 49%. So it guessed, it said, that's my guess, 50-50, I might be right. We as human beings can see that it's not right, but that's what it came up with, and at least it's honest about it. And you can see here that black and white is true, and line drawing is, it is a line drawing. All right, so if this is just this for the, what category am I in? The computer vision API. There's analyze an image, which I've been going through right now. Read text in an image. That'll give you essentially optical character recognition. Turn pictures of words into words. This one here, let me look at really quickly. You'll see that it came out, if we did all the things we are capable of doing, it's doing pretty well. It gets down here, down at the bottom, ourselves. It thinks the O is a Q, and that's because of the background here. And then at the ES at the very end, I think as this texture behind it gets wrong. So the higher quality your images or the higher quality your text is, the better job it'll do. For example, if you have a lot of kerning, in other words, if letters are running together, that'll degrade the quality of the optical character recognition. It can even do it with handwriting. This is actually a pretty new one here, where it actually read handwriting and turn it into text. Really powerful stuff. Recognizing celebrities. You can give it a picture of a celebrity. In this case, this is a celebrity of a man named Satya Nadella, who happens to be my boss's boss. And it recognized him. There's Satya right there. There's a face rectangle around it. And so on. Let's see, what else do we have here? Analyzing video. It can do descriptions and keywords or categories of video. It can even do like a compressive video into a small thumbnail by picking out the interesting spots, or maybe whenever there is motion, it can pick that out, the time when something happened for security stuff. Generating a thumbnail. That sounds easy, right? I have an image. It's a big image. I want a thumbnail of it. Maybe I want to automate that process. If somebody says, "Hey, send me a picture. You're speaking at my conference, so I want you to send me a picture of yourself, but make sure that it is exactly 200 pixels by 200 pixels." And then they've got to resize themselves a little bit. Why not just say, you know what, just send me a picture of yourself, and I will worry about resizing it, making it the right size. It sounds simple. You just shrink it down. But what if you have a rectangular picture and you want to turn it into a square? Or you have a picture that is of landscape orientation like this one, you want to turn it into a portrait orientation. These would require cropping the image in some way. And if you crop the image, you risk cropping out the most important part of the image. So what this will do is it will look and see what is the most important part of this image. And we as humans can see that clearly this person standing on top of a rock is the most interesting, most important part of that image. And so it'll try to keep that person in there if it can. If it gets too narrow, it can't do that. And then, so these are just for the computer vision API. And there are lots and lots of APIs in there. So if I go back to these categories, you'll see just under vision one, we have computer vision, emotion, video indexer, face API, video API, content moderator, custom service. Under speech, we have speech to text and text to speech. Under language, we have some sentiment analysis and language understanding, so we can actually parse out sentences and figure out the meaning of sentences. All kinds of just translator, speech API. All these things that are knowledge API, all the Bing stuff is now moved into cognitive service here. So if you want to do auto suggest for Bing searches, you could do something like that. All right, let's actually use some of this stuff. So let me go back into the computer vision API here. And you can look at the documentation. This is a great place to start with an overview, requirements. Here's the JSON that comes back. Let's see, scroll down a little bit. Here's some of the data that you'll see. And this is really just telling you about the image here. It's not specific, technical specifics of how to call it. If I want to actually call it, I want to look at the API section. Which is here, API. And here's the technical details of actually called. It is a web service. It is a RESTful web service. And this is really good news if you're not a Microsoft developer, or if you are a Microsoft developer. It doesn't matter. Yes, these are hosted and maintained by Microsoft, but they are exposed as a RESTful web service. And what that means is that because it's REST, because it's a web service, and because it's sending and receiving JSON, and because all those things are standards, are industry-wide standards, then you can call it from any operating system, any language, any platform, as long as those platforms support web service calls and sending and receiving text and pictures. So for example, way down at the bottom here, you'll see, here's how I'd call it from curl. Here's how I'd call it from C#. Here's how I'd call it from Java, from JavaScript, from Objective-C, from PHP, from Python, from Ruby. All these things, all these different languages, you can run them on a PC, you can run them on Mac, you can run them on Linux. It doesn't matter because it's just calling out to a standards-based web service that sends and receives JSON. And here's sample. I don't know anything about Ruby at all. First thing I was doing, if somebody says you have to write a Ruby application to call this, I would go in here and I'd copy that code and modify it to meet my specific requirements. Go back up to the top here and you'll see the API and how you call it. So here's documentation on it. When we say REST call, we're going to submit to a URL, to an endpoint, and that URL is going to be this one right here: https:// location, and there are 5 different locations for it, .api.cognitive.microsoft.com/vision/v1.0/analyze. You might want to just copy and paste that. It's kind of long. But we're going to post to that URL. With HTTP, you can use, there's a bunch of different verb methods you can use: post, put, delete, and patch, and get are the most common ones. So we're gonna post to this URL right here, and then we can add some optional query string parameters. So this question mark, anything after the question mark is called a query string parameters. There's a set of visual features, a set of details, and languages. So if I scroll down here, they explain what each one of those are. Visual features is a common limited list of all the information you want to get back from your service. So if I specify categories, comma, tags, comma, description, that's what I'll get back in my JSON. My return response will return a list of categories, a list of tags, and a description of it. If I want all those things, I just include them all: category, comma, tags, comma, descriptions, comma, faces, comma, image type, comma, color, comma, adult, and all that information will come back. Of course, the more information you put in there, the longer it's going to take, and the larger the package will be, so the transport will also be a little bit longer. So if you don't want things, you can just omit them just to speed things up a little bit. The second one is details, and the details, there are two possible details. You can do them both: celebrities and landmarks. Celebrities will match a set of known celebrities. So if you send it a picture of Tom Cruise, it should understand that it should recognize Tom for who he is. And landmarks, if you send in a picture of, say, the Sydney Opera House, then it should recognize that is the Sydney Opera House, because it's seen lots of pictures of that. And then the last thing is language, way up here. And we can set the language equal to, right now there's only 2 languages supported: English and simplified Chinese. Hopefully that will expand as time goes on. So for example, in the OCR, the text recognition, then there's actually like 20 languages that are supported in there. That's the URL. So right here, back up to here, https:// some location.api, etc., and these query string parameters afterwards. You're going to post to that. When you make an HTTP request, there is always a set of headers that are included with that, and you can manipulate those headers. In this case, you need to add a content type. Actually, you don't need to. It'll default to application JSON. But you do need to add this OCP APIM subscription key. And the subscription key is how it knows that it is you, that this call is yours. So for this call, I think we get about 5,000 calls per month with the free account. And so if I call it with my key, let me actually open this up in a new tab, and we'll see. Then here I'll have a key, and what will happen is I'll send my key in the header, and then it knows that it's me, and it'll decrement it down. I'll only have now 4,999 left. If you need more, there is a non-free account. If you need more, 5,000 is in a month. Let's say you're building an iPhone application that's calling this, and you're putting it into production, and you're going to get way more than 5,000 calls a month. You can buy more, and the pricing is available under pricing on Azure. But in that case, it also knows who to charge, because you get so many calls per penny.
So I did a question here.
Yeah.
Now, I know you're not a lawyer, but do you know, the question is, if our apps use cognitive services, does it give rights to Microsoft over the images that are uploaded?
Does it give rights? I don't think it gives any rights to them. There is a period over which it can retain them, and I've heard different answers to that one, that it may retain them for, I think, like 10 minutes. In case you make the same call again, you can retrieve information about the same image twice. But there is I'll see if I can find it later on, but there is a page, if you go back to...
So I just added a link in that answer that I just sent with the terms of service, or the terms.
Yes, that's where I was going to put you.
Yep.
I was going to point you to, is the terms of use includes in there a long bit of legalese about what we can and may do with your images, what you're agreeing to. So did you find it in here somewhere?
I just, Googled with Bing, and I put that in the chat window. So I put the link there to the terms of use for cognitive services.
Okay, it's in here as well, but they've recently changed their, redesigned this website, so I'm not sure exactly where it is right now. All right, good question. Let me go back to, where was I? Here, yeah, here. So here I clicked on Manage Keys, and if I show access keys, this is my super secret keys right there. So don't let anybody ever see these. Let's click to copy that. I trust you guys, all right? You're not gonna steal my keys. I'll put that in there. And that's my super secret access. I did that just by clicking on that. So this is what, in the header, I'm gonna add that, my key, my subscription key. You may have noticed that there are actually 2 keys here, and that's if one of them gets compromised, I can regenerate them and show another one. So I'll add that in the header, and I'll also add the content type. The content type is described down here. It can be either application/JSON or application/octet stream. And the difference between these two is how am I going to send the image in the body of my request. If I select in the header content type is application/JSON, then I'll send the image as a link in this JSON format. So JSON is just these name value pairs, URL : some image at a publicly available site. It has to be a site that cognitive services can get to. So you can't have a site on your hard drive that's private or something behind a firewall. It has to be available to cognitive services. If I want to actually send binary data, I actually have a couple of options. I can either do application octet stream or multi-part/form data. Those will both send binary data, and just depends on whether I'm going to do it through posting a form or through an octet stream. I suspect if you're doing a mobile device, you'd probably use application/octet stream for that. So depending upon what I put here in the header under content type, that determines how I'm going to send and what I'm going to send in the body, whether I'm going to send JSON or I'm going to send the actual image itself. And that's the request. It's a really simple request. And you could do this through tools like Fiddler or Postman, or you can do it through languages like C# or Swift or Java or PHP, just about anything. Now, once you make that request, you will get a response back. Hopefully that response is 200. Anything that starts with 200 is a good thing. That means that everything worked well. There were no errors. And if you get a 200 back, then you'll get something that looks a lot like this, categories. And if you look at the documentation, it'll actually describe what everything in here is, but I think they're named really well. Categories, there's typically a score for each category, specific confidence level is how confident they are that actually is what it says it is. So this one, we said celebrities, and so it's returned Satya Nadella. We said landmarks, so it must be Satya standing in front of the Forbidden City. He's not in any compromising positions yet, not adult or racy, and some text, man, outdoor window, and so on. I guess he was sitting on a bench in this picture. They don't actually show the picture that this one came from, but this is an example of it here. And it's pretty easy to read that you can see what everything actually is going to be in this. So if you don't get a 200, if something goes wrong, then you'll get a response that starts with either 400 or 500, usually 400. And things that could come back are invalid image URL. So that was, let's say you send a picture that it couldn't find the picture, or it's not a valid format. I think JPEGs, GIFs, and pings are all supported. So if you send some proprietary format, it would stop that. Too large an image, I forget, I think it's like 4 gig is the largest image. I forgot, it's documented in there, but if you send an image that's too large, it'll fail on that. If you misspell one of your query string parameters, if you, this is interesting, if you try to send it child pornography, it won't even return a value. It will crash and burn and send you a 400 back. So it's don't, I know you guys wouldn't do it, but tell your friends don't do it. And invalid, again, this if you misspell something here. And then you get actually an error message which will help you determine what that is. And here's some more specific things. You know, a really common thing to do would be if you got that key wrong. Let's say you put the wrong key in, then you'd probably get a 401 that it didn't authenticate. There's actually a very rich set of response codes built into HTTP, and you'll get those back, but you'll also get a description, a message, you know, invalid media type, which will give you some more information, how you can handle that in your code. All right, so that's it. For this one, pretty simple. If you want to learn how to do it in C# or Java, there's sample code right here. So you guys are Xamarin developers, so C#, you would use this. This is just a console app, but you can see that there's this HTTP client object that it's a library that comes with .NET, and it allows you to add headers and query string parameters and body. Copy and paste this code as a starting point. It works really well. Let's actually make a call on our own.
So real quick before we do that, David,
yes.
We had one more question. A little while ago, you were talking about the location tag, if you remember that. And wonder if you could quickly just, again, go over what that location tag was for.
The location, oh, this right here.
Yes.
Is that what we're talking about?
Yes.
Okay, so these are the data centers, or rather the regions. The regions usually have 2 data centers in them. These are the regions of Azure that support cognitive services. So what I would do is I would create your keys in the region that is closest to where your users are. So if you're selling an app and you expect it to be used in Europe, I would use this one. If you expect it to be used in Southeast Asia, I'd use that one. So whatever one is closest to where your users are. And you can actually create multiple keys if you want to.
Great, thanks.
And that just goes in here. In fact, here, if I click on West US, then that will fill in this for me somewhere down here. There it is, westus.api.cognitive. So now the URL is actually more complete, like there. And what I'll do is I'll up this little console here and say, here's what I want. I want to select, I want to return description. I want to return details, sure, celebrities. I want it in English. And that's it for the query parameters. Content type, application JSON, subscription key. Is it still on my keypad? I think it is. Don't look, everybody turn away. There we go. And then, so that's my header right here, content type and key, because I selected application/JSON. I'm going to, oh, here's the maximum size, 4 megabytes. I think I said 4 gigabytes earlier. So these are restrictions. It must be less than 4 megabytes, and it must be greater than 50 by 50, and these are the supported formats right here. All right, so this is a sample. That image doesn't exist. I'll have to grab an image. Let's find one here. Why don't we go out to bing.com, and we'll search for something here under images. We'll call it, let's look for Rob Gibbons. I always spell his name wrong though, so let's get a picture of him. Oh, you're dominating this. Oh, look at this right here. We'll see if he's actually shows up under celebrities.
Perfect.
So right there, copy that. This is, we don't have video on this, but this is actually me and Rob talking to each other. I didn't do this search beforehand. I just randomly picked it out. All right, so there we go. It's a JPEG. Doesn't look like it's too big or too small. And this is the request right here. There's the URL with the query string parameters that I've selected right here. Information about the header, content type is that. It does obfuscate the key right here, and there's the body of it. So if you want to go to Postman or Fiddler or something like that, you could actually do the same thing. Just copy and paste everything here and grab your own key for that. Let's send it. This little test console. Oops, click send. it'll actually make that call. And I got 200 back. Yay, it worked. So I should get some data back. And I have, let's see, this JSON description, person, the tags are person, outdoor, man, grass, holding, standing. Those all look pretty good. A man holding a frisbee. It's not a very good one.
And we are not celebrities either.
And this is probably, it's probably thought this was a frisbee right here. I'm wearing an Orlando Code Camp shirt. But it recognized 59%, so it wasn't super confident that it was a man holding a frisbee. And then does the celebrities are, I said celebrities, but we're not famous enough yet to actually fill this in right here. Let's actually do a celebrity. Rob, hit me up with a celebrity. Who's a good celebrity?
Jimmy Buffett.
Jimmy Buffett. So there's a good picture of Jimmy right there. And I'll go back to this just to see if we can, if this engine recognizes. Let's see if there's a parrot head behind this thing.
And this will be interesting because in that picture there were sunglasses on, so it's partially obscuring his face too, so we can see how powerful it is.
I bet there are a lot of pictures online of Jimmy wearing sunglasses.
That is true.
So I got 200 back, and celebrities are. Oh, wait, let me make sure I didn't. Let me do it again really quickly. It did get sent. So you're right. That did not recognize the celebrity, and probably because of the hat and the sunglasses, it wasn't good enough. So all right, fair enough. So this is a tool. Let's do some actual code, shall we? I've got some samples on here. I've got one Xamarin sample that I just wrote last night, but I'll show you a couple other ones here really quickly. I've got, looks like 22 minutes left. So in this one, I have analyze images. This is a, I think it's a WPF application. Well, that's going on, since it's going to take a second to launch that. Maybe I'll grab a couple of these here. Come on. Here we go. While that's loading, I'm going to take a drink of water, but I'll mute myself as Rob requested. That was a good drink of water. Okay, this is, in this application, this is all written in C#, and you can see that what I'm doing here is I have, I get my key, pull it out of a config file in this method here, and I create this HTTP client. Let me go full screen so you can see a little better. Right here, HTTP client, I'm going to add my key in the headers. I'm going to add some query string parameters, visual features equals everything. I want to see all that information. Language is English. There's my URI west.api/blah. I have actually a drop-down list with a bunch of URLs in. I'm just going to grab the URL from whatever one's selected there, and then I build up my JSON URL : whatever is selected in the drop-down list here, encode it. This code I just copied right out of that web page where it says C# code right here, and then I'm going to use my HTTP client. There's a post async method which asynchronously posts to a web service URI, and it passes in the content of the JSON that I created. I get back this HTTP response right here, and I check the success. So is it 200? If it is, then I want to analyze it. I get the string data out of it. It's a bunch of JSON. I'm going to use the Newtonsoft JSON library. So you can just go right-click in the Visual Studio Project and add a NuGet package from Newtonsoft.json. That's what I'm using here. And once I get the results I can pull down results.description.captions and pull out just the first caption text. and display that. And get all the tags and loop through the tags. I just display all the tag list box and so on. I also check the RACI score, and if the RACI score is above 0.3, then I have this image that I show that indicates that it's a RACI score. Don't worry, I think I have one image that's like 0.31. It's not that RACI, but just for demonstration purposes. So here's an image right here of a kitten, because the internet it was built on kittens. Analyze it, and this text box should say that it is a cat looking at a bird. I see cat, animal, white, outdoor, etc. That's pretty good. Analyze this image. A bird flying in the air. Bird, animal, raptor, outdoor. This was doing pretty well so far. I think this is my RACI image. There we go. This picture of a guy with his shirt off. And let's do that. It does come back as slightly RACI. So Macaulay is shocked by this. A person posing for the camera, clothing, holding, standing, etc. And so, actually, I gave this talk at Disney one time, and I was really excited to go speak at this Disney conference in Orlando. But before I went, I added this extra picture because I totally wanted to make a good impression. So I did this picture of Luke Skywalker, and I analyzed that, and I got back. It's interesting. Mark Hamill holding a tennis racket. So it recognized Mark, but it doesn't recognize the lightsaber. I thought that was kind of interesting. But no. All right. I'll close that one. And then I'll do this emotions demo. In this case, I have a drop-down list that adds just a bunch of pictures to it, and click a button. It will call this get emotions right here, where I get my API key, pull that out of a config file. This code is the same. This is the last one I saw. HTTP client added the key to the headers. My URI is a little bit different. This is the web service is /recognize. The last one was /analyze. Shouldn't be a space there. And then I have this response here, HTTP response right here, but I build up my JSON URL : whatever the user selected from a combo box, and then I just prepare that and call client.postAsync. Passing in my web service and the content. And then it's asynchronous is a wait keyword, means that it's called asynchronously. It doesn't lock up anything, but the next line, this one right here, won't run until this thing actually gets a callback. So it basically makes the rest of this a callback. If you're not using the await keyword, you should take a look at that. It's really nice, elegant syntax. If I get a 200 back, then I want to, again, read the data and serialize it. And here I've actually, I actually have cast this to a face object right here. So it's going to come back as a face object, or an array of faces. That's what it's returned. And I want to get strong typing in here. So if I go to the definition of a face, you'll see that the face has a rectangle and a scores. And if I go to the definition of each of those, the rectangle has a height, left, top, and width, whereas the scores has properties for anger, contempt, disgust, fear, happiness, and so on. These are just numbers. They're numbers between 0 and 1. So I'm going to get a strongly typed array back, and I can start looking at each one of those faces. And that's what I do here. I loop through every face, and I look up, the For each face, I get the face.scores, and I get the score for anger, contempt, disgust, etc. And I just start building up a string to show the score of each one in a friendly manner. And then I also do this right here. I do this link expression to say what's the maximum score and what is the associated with it. So I can output to say the maximum score is one is most likely to be experiencing this right here. And then I also do just a raw JSON that comes back. So let me run this thing here, and you'll see for each one, I'm going to display the raw JSON, a nice formatted list of all of the emotion scores for each face, and then the likely emotion of each face.
So as we're waiting for that to load, question, are we going to be able to take a look at the sample code afterwards? Can you make
yes, the sample code is available on my GitHub repository.
Excellent.
And I have a link to that at the end.
Yeah.
And we can also add it in the other show notes for this.
Yeah, we can do that.
I think my app might be loaded somewhere that I can't see it. Is that right? It is running. Is it running?
Looks like it's still building down at the icon down the bottom.
Yeah, this thing right here, I see it is doing something.
What's the output say? The output window. Build started.
I just ran this last night, so I'm surprised that it's taking this long.
Maybe stop it and try running it again. Sometimes Visual Studio gets.
How do I stop it?
Under build or debug menu at the top, I think. Or right there, cancel. Under the build menu. Down at the bottom.
I'll try it again.
Looks like it might have got hung up on NuGet.
While that's building, I will show you my GitHub repository. github.com/David Giard. And right here at the top, Cognitive Services Demo right there. And there's a bunch of different demos that I have here. I don't know if I'll get to all of them today, but you can download these and play with them. You'll have to replace them with your own key. I think I've either obfuscated the key in here or I've changed the key since I checked it in. So you'll have to create your own key and use that. And this might not work.
All right. Mark on the question says, I think there was a file not found error message just after canceling the build. So try canceling it again and see if it gives us a better message about something.
Processing development, getting definitions performing.
Expression cannot be found.
I don't see it.
Yeah, it looks like it's just not most likely a certificate file. You don't need that. Oh yeah, the emotions demo _ temporary fix in your Solution Explorer has the warning on it, which I believe is your Windows developer key.
I don't know why it's doing that. I did, if I do the emotions, well, let me see if I just run the last one. That should run it. Oh, here it is. So this is what I ran it yesterday, and it's still installed. So I'll at least show you the results of it. Here's a picture of an angry little girl. I get it back, and it does work. So I get back an array of one face. There's a rectangle, scores anger, contempt, etc. It looks like anger is pretty high. And then I just format it a little better, anger is 92%, contempt, and everything else is 4% or less. And I have here, face 1 is 92% likely to experiencing anger. So let's scroll down here. Is oh, it looks like this is the problem with images online, is the picture is gone. I was trying to add a picture of sad LeBron. Here's one right here. So there's a picture of a bunch of shiny, happy people. Let's get all their emotions. They should all be happy. There's an array of looks like 9 different people, and they're all experiencing happiness. Some of them 100% happiness, some of them only 98. I'm guessing the 98% happiness would be like maybe this person right here whose face, or this person right here, their smiles are slightly obscured by the person in front of them. And what do we have here? Oh, here's 3 different, actually the same face, 3 different emotions. Grab that, and you can see that they are neutral, happiness, sadness. Now this is interesting. You notice they're not left to right, neutral, happiness, sadness. So to use them, you'll have to look at the face rectangle and bring that back. So if you want to match them up, here's my my required Star Wars reference because it's Disney, and this is Adam Driver. He has exactly the same expression throughout the entire movie. He's always neutral. Good actor and all, but my gosh. And then somebody asked me I should do the Mona Lisa, so I did, because of her enigmatic smile. And what do you think it is? Comes back as 75% neutral. But it hedges a little bit, 24% happy, 75% neutral. We're not really sure. All right, close that. And we'll close that. And we will open up, let's do a face demo right here. In this case, actually, I'll show you the code first of all. The code for this face demo. This is all in JavaScript here. So I get my subscription key, and in this case, I just have a text box where you can put the URL of an image. Here's the web service I'm going to call right here with all of the query string parameters added to it. And this is the face API. It's going to return lots of information about the face, and including like face landmarks. Where's the nose? Where's the eyes? Where's the mouth? Is the face wearing glasses? How old is the face? Is it tilted? Which way? Is that facial hair? How much is it? Is it bald? All sorts of things like that. So here I'm going to do a call to a post to my web service. My headers are my subscription key and the application or the content type, application JSON. My data is URL : and whatever the user types in this text box, which is where the picture is. And this is asynchronous. So when I actually get the call back, then I get this right here, which is an array of faces. So I just make sure there's at least one face in there. And then for this demo, I'm only going to look at the first face. And so I grab the first face and I get the face ID. There's actually a GUID if you want to tie it back to this. The rectangle, and the rectangle has a width, height, top, and left. And I'm going to use some CSS to draw a yellow rectangle around where the face is. I get the face landmarks right here, and the face attributes, and pull out things like pupil left, pupil right, mouth left, nose left, alar out tip. The alar is that part near the bottom of your nose that just covers your nostrils. And I pull out all this information, and I want to put a label on where the eyes, nose, and mouth are. So I get the center of each of those. So I'm doing a little bit of math here. I use CSS just to put some labels on the eyes, nose, and mouth. And that's all I'm doing here. So if you see this in action, here's the face. It calls out to here, and I draw a rectangle around this. And I put. So if you want to do something like, face swapping, this would be a nice thing to do. Way to do it, exactly where his nose, mouth, eyes, and are. Other information like his age is 55, he's a male, he's smiling, 37% smiling, he's wearing reading glasses, and so on. All kinds of information right there. Now this is in a great way. There's actually a security flaw in here, and the security flaw is this. I am sending my subscription key. I'm actually bringing the subscription key down to the client, and then I'm sending it back to the server. That's a security flaw. I really shouldn't expose my subscription key that way. Even though this HTTPS is still, that's a problem. What I really should do is I should, instead of calling the service directly from JavaScript, I should call cognitive services for my own web service. Put just a proxy in front of the web service, call my service from JavaScript, and then my service does nothing more than look up the key on the server, and then it calls cognitive services. That's a much better pattern, much more secure pattern for anything like this that requires some secure piece of information to be translated. In fact, I would suggest the same thing maybe for if you're building a mobile application. And in fact, I did that. I'm not going to show you the code here, but it's in my GitHub repository. This face API protect key demo is exactly the same thing. I've got a, it does exactly the same thing as that face demo I just showed you, except that it puts a proxy in front of it that just looks up the key, the API key, and it calls cognitive services. I'll show you a couple other ones here. OCR demo is here. This will look at pictures of text and it'll turn them into text. What it does is it returns an array of text regions. So each, if you've got a block of text up in the top left of your picture and a block of text in the bottom right, that'll return an array of 2 blocks of text. And then within each region, it'll return an array of lines of text, and within each line, it'll return an array of words. And the reason it does this is because with each word, it also includes the location, a rectangle of the word. So you can specifically find each word, and if you wanted to replace an entire line or replace just a single word or maybe black it out, you have that kind of control to do that. So what I'm doing here is I've got a bunch of images of text and a drop down for languages. There's about 20 languages supported in this. And then I just call this function here. So when you click on the button, it says get the image, get the picture. Let's see, where is it? Right here. We click the button. It gets the URL of the image of text. Make that a little bigger. There. It gets the language that I've selected. I get my key. I look up my key. That's the URI I'm going to call. It's under the Vision API /OCR. And I add the query string language equals that language. And then I'm just going to post to that web service. The headers will be my key and app content type application JSON. The data will be URL : the URL of the picture. And when it's done, I loop through all the regions of text. I'm not used to using this trackpad here, sorry. When it's done, I loop through all the regions of text, and then I loop through all of the lines of text within that region. And all I'm doing is appending together, you loop through all the words within each line. I'm just appending together a string and outputting that inside of a div. So if I run this thing, should, let's do it, F5. And here I've got a poem by Robert Frost, the famous Road Not Taken poem, and it's in English, so I say get text, and it displays down here 2 rows diverging yellow. You see 2 was wrong, and the reason is because the text quality isn't that good. It's italicized, there's some kerning going on. This one right here is a little bit better. Listen, my children, you shall hear the midnight ride of Paul Revere, right here. And that actually works better, it's just better quality text. And I can do this for, here's one that's not very good text. The other side words are leaking through. It's got this weird spelling of where they used to use F's instead of double S's, and son is misspelled. The big M causes problems, etc. And so you'll see issues with that, where the M is over here. It got mistress right, and it got son right. Nothing is a little bit, the better the quality test, the better it's going to be. And this actually works in multiple languages. So here's Spanish right there. So this Spanish returns Spanish text. And I've got some examples here in French. I even have one in Japanese I just recently added. So I specify that and get that text. Look at that, perfect. All right. All right, we're at just about 60 minutes right now, so I want to jump to my Xamarin demo. So I just wrote. It's way down here. I've got other demos here as well. The Xamarin demo isn't yet on my GitHub page because I just wrote it, but it should be there in a few days. I'll try to get it there today, but I'm flying to Stockholm tonight, so I may be pressed for time.
And for anybody who does need to go, because it's been about an hour, this is recorded, so we'll have this up on the Xamarin University website in a day or two, and you can catch back up with that. So just so everybody knows.
All right, I'm going to go ahead and launch this. Let's see. Wait for the spinning thing to go away. Okay, I'm going to start this. Usually it tells me what device I'm going to run this on. I don't know why it's not doing that. Well, let's find out what happens. Let's start. And oh, I didn't do that before. There it is, running on a 5-inch KitKat. I guess because I didn't hit I don't have a max wired up. So as that's running here, let me show you the code. This is a portable class library up here, and the code is called from here. So what I'm going to do is I'm going to call this get emotions right here and pass this an image URL. In this case, I just hard coded the URL. It's the picture of the woman, the 3 faces, the same woman, once she's smiling, once she's crying, and once she's neutral. And I'm going to pass that in and to this method right here. Requires internet connection. And get my key. And this code right here is really similar to the one that I did in the WPF, or the Windows 8 application rather, Windows 10 application, excuse me. Add some headers. There's the URI of the cognitive services. It's emotion/v1/recognize, and there's my JSON. That'll be the body URL : the picture of the 3 faces. Prepare that to post it, and right there is post async. And when it comes back, I should get this back. It should be, if it's a 400, or I'm sorry, it's a 200, it's all good. I'm going to parse it all out and just return this array of faces right here to here. And once I get this array of faces, again, I've strongly typed this, so each face has a rectangle and a set of scores: anger, happiness, sadness, neutral, etc. And then I do this parse faces here. And what this does is just loops through, and it's the part of the code that figures out what is the highest score and what's the emotion associated with that score, and then formats a string. So I'm just going to return this format string, face whatever is most likely experiencing this, or there's X% experiencing this emotion, and return that. And then I just display that right here. So as this is coming up, it's still starting the emulator. This takes a minute. Let me just say that the reason that I do this talk is not so much so that you can memorize the code that I'm writing and write the same code and call the same one. The reason I do this talk is because I want to show you that this technology is really accessible. That it doesn't take a ton of work to add some really, really cool features to your applications. To maybe, if you've already got images in your application, maybe you want to analyze those images in some way. Bring back some information about them. Are they smiling? Are the people smiling in it? How old are they? What do you have pictures of? Maybe categorizing your pictures. These are all cool stuff that you can add to your application. And in fact, the YouTube video that I wanted to show you at the very beginning, but I can't transmit sound, I would encourage you to go here. This is a project. It's only 2 minutes and 44 seconds. Watch this video. This guy, he's blind. He's been blind since he was a little kid. And he's using this technology to change his life. When he's in meetings, he's got these glasses on, which will take a picture of the person in front of him and tell him in real time, this person is smiling. This person looks interested. Tell whether they're engaged or not. Look around the park and see, what's going on around you. Look at a menu in a restaurant and read the menu back to him. It's really just amazing stuff that literally changed his life. And you can do the same thing. You can take this as inspiration to add features that would make your application just amazing. Oh, Bradford's is ringing. Didn't like that. I'll try it one more time. After it stops.
Well, if this is Xamarin Forms, do you have a Windows solution as well, or Windows project in this solution? Then you won't need the emulator at all.
I do. I haven't run that one. Let's try it.
Well, the beauty of Xamarin Forms should just work.
It should just work, absolutely. The emulator should just work too. All right, so I'm going to set my UWP as my startup and try this again. I probably don't have.
So change that to x86 instead of any CPU for UWP.
Oh, okay. Well, that's running. So to complete my thought, what I'm hoping is that those of you that are on this call that are watching the video, you'll start thinking, I've got this application and it does this, and this would fit right in. I could add just a few more lines of code and make it way more awesome just by calling this web service. The hard work has been done for you. The machine learning part is done for you. It's up to you to apply your imagination to your project, to this set of services to make it much more amazing.
And for those who haven't seen it, we have a series of webinars going on in June, and one of them coming up is a webinar by Jason DeBover, who's going to do Azure Machine Learning. So we can get caught up on that side of it as well.
That one failed with just the app did not start, generic message. I'm gonna try this one more time, and then we're just gonna leave it up as an exercise to the. The first time I clicked this, I didn't wait for everything to load, so I'm thinking maybe that was the reason why it failed. Xamarin can be a little bit finicky sometimes. I am using the Microsoft emulator and not the Android, the one from Google, which runs much better on Windows and much faster.
Yeah, the Visual Studio one should still work, although it is deprecated, so it's not going to be supported in the future. But definitely suggest using the Google ones. But always an issue with the Hyper-V and things.
Yeah. Okay, so we're not going to be able to show this demo here, but what I will do is I'll post the code to my GitHub page, and you can check that out later on. And I will leave you, don't say that, with these links right here. So if you want to learn more, this is me. Follow me on Twitter. Read my blog. Send me a message. I'm happy to hear from you. These are the links. This is everything I write about cognitive services or talk about it. I put a link on this page right here. These are the two websites I showed at the very beginning. This is the project the YouTube video that I showed you. It's the blind fellow that has is using cognitive services to enhance his life. This is the way that Uber is using cognitive services, requiring their drivers, in addition to logging in, they have to take a picture of themselves and match that up to a photo in their database. And it shows how that's actually increasing security at Uber, so you don't accidentally get, Joe goes through the security check and gets certified as an Uber driver, and then he hands he gives his login credentials to his cousin Freddie, who has never been through that security check. This prevents that. This is where you get started. Microsoft.com/cognitive is a shortcut to it. And the last one is a link to all of my demos. In fact, actually, I'll put this in the chat window. I have all these links. How do I do this? Here's chat. And down there, if you look in the chat window, you'll see all those links are in there, and you can just copy and paste them right there.
Yeah, and if you want to copy and paste those, do it soon, because as soon as the GoToWebinar exits, you're not going to have access to that. So if you'd like those links, copy them now, I would suggest.
Okay. I can send them to you, Rob, as well, so you can get more publicly accessible.
Yeah, so when I post the video on the Xamarin University site, I'll also post these 3 slides as a PDF, and you'll be able to download those and get links directly to all the things that David has talked about today.
Rob, thank you so much for having me.
Thank you.
Audience members, thanks for coming, and I'll see y'all later.
Great. So yeah, I mean, Azure's got a ton of stuff. Obviously, we could talk for days and days, but thank you for this quick tour of cognitive services. Definitely, like David said, see what you can do, see what you can add into your applications, and take advantage of, like David said, all the work that's gone into this. And I'd also suggest, David travels more than a rock star, so he's probably going to be somewhere near you, wherever you are in the world. Go out to a user group or a conference and say hi.
Absolutely. Here's where I'm going to be. I'll give you that right now. I'm heading to tonight, but I'll be back. So maybe in Stockholm, you can see me at DevSum this week. But this site right here shows me. It's linked from my blog, and it'll give you the.
Cool. So yeah, just davidgiard.com.
Yeah,
right, so thank you, everyone.
Eventually.
Thank you, everyone, and look for the video up online in a couple days, and we'll see you in our next guest lecture. Thank you again.
Thanks a lot.